Hey, I'm Steve Alviti, and today we're going to talk about one of our clients who came to us is a precision machine shop, and they manufacture airfoils for the aero industry. All right. Currently, they're running a process in a centrifugal barrel as step one. Then they're going to their machining op, and then they're coming back to a second step in the centrifugal barrel, and then to a clean, rinse, and dry. Some of their current issues that they'd like to improve upon are, number one, they have to transport their parts to and from the finishing area and the machining area. Another point they'd like to improve on is their excess manual labor in the centrifugal barrel operation. So today we're going to kind of show you our process of what we go through to improve their current process for finishing. So to help our client, they send us some parts from the different steps in their processes. What we do is we analyze them on our Z gauge here. We take a look at the surfaces, the specifications of the print, part geometry, and understand what they're currently doing, so that way we can better help them and improve what they want. So our proposed solution is our centrifugal disc finisher. We can mimic the actual process done in the centrifugal barrel, but the advantage here is that, one, we can have this right at the machining center, where the machining operator can load and unload the process in seconds compared to 10-15 minutes. So we're going to run a two-step process mimicking the centrifugal barrel process. At the end of the day, we were able to match the finishes in the centrifugal disc finisher. We were able to save money on labor, we were able to save money on real estate, and we were able to improve the ergonomics of the production workflow with cellular deburring right at the machining op, and increase your throughput. So big win for the centrifugal disc finisher and our precision client and for Bel Air Finishing.